Good morning all. Today I'm going to take a look at this thing, which I've had for a while actually, and I've been using, and it really does work very well. It's a charge controller, or it can be configured as a discharge controller, and it has two voltages, a lower voltage and an upper voltage, which creates a hysteresis band. So you can get it to turn on the relay if it goes over the upper voltage, and then turn it off again if it goes under the lower voltage, or you can get it to do it the other way around. So if you were using this as a charge controller, you could have it so that it's attached to a battery, and when the voltage went below a certain lower threshold, you could get it to turn on a charger, a mains charger for example. That would charge the battery back up, and then when the voltage goes above the upper threshold, it could turn the charger off. But when it's working as a discharge controller or a load controller, of course it works the other way around. But let's power this thing up. I've got a feeling the input is anything from, it doesn't say, but I think it's 6 to 60 volts or something like that. In fact, why don't we start on the eBay listing? Let's go over and have a look at that. So this is the item I bought. You bought this item, £7.46. I think I paid a slightly different price, but they keep changing the prices. 71p postage. And it came from AI Smart in Shenzhen, China. Now there are two types. Without shell is the one I bought, which is the sort of open PCB with the relay and the display. With shell, it's in this box, which I didn't think would be as convenient. So yes, I bought the without shell type, this one. And what have we down here? Oh, all sorts of pictures and instructions, but they're pretty unfathomable. So I'll go through it bit by bit, but first I need to set it up on the bench with a power supply. So first I'm going to take off these cables which I made up really horribly actually, because I really wanted side entry, and this has got sort of two top entry positions. So this is the cables I've been using on my solar crypto accumulation machine, and as I say, it works extremely well. But let's rejig it so that it's on a power supply with a knob that I can twiddle so that we can test the upper and lower voltage thresholds. I must get some silicon versions of this wire, because this wire's really very stiff, and when it's cold in the shed, which it pretty much always is at the moment, this stuff's rock hard and doesn't flex at all. You might have seen I had an item in my shopping cart on eBay, or shopping basket I think it's called in this country, and that is some 40 amp silicon wire, so I think I'll get some of that. But for the purposes of this, all I really need is some very low current wire, and I think I'll use my 24 volt bulb on the output. So to bench test this, I think I'm going to use this power supply, which is one of those Rui Deng ones with a sort of display module, cables, and then I think this is the buck boost one. So with 12 volts coming in on my bench, I can boost this up to 24 for that bulb. Let's try that. That's interesting. These are totally different. I don't know whether they've got mixed up with something else. These have got flat slotted bolts in them, and they're the sort of pull draw types which pull a drawer closed, whereas these are these horrible bent leaf ones and have flips or posi drive screws in them. It doesn't really matter particularly. I want to put that in there, so that's going to be fine. I'll get my pos and my neg the right way around. Let's do that. Right, so that's on there. Pos to the top, in pos. That looks the right way around. Let's put my bench 12 volts. Oh, I don't have a display, do I? Right, that's the display. These don't sort of sit down properly. I'm going to have to get some blue tack, I think. Let's plug that in. Is it going to work? Yes. So 12 volts going in, and I'll set this up for about 25 coming out, or 24. This is a 24 volt bulb, and I'll get a couple of wires to go from here onto here, but they can be quite small. Right, that's it wired up. Where's my pointer? But I don't want to switch it on because this is set to 32 volts. So I think we press V, and then what do we press? Do we press that to move through the fields? Yes, we do. So if I bring the digits down, so let's set that for 24 initially. No, let's set it for 18 because I really want to work within the range of this bulb. So I think I'll work between about 12 and 24. So let's set this to start at 18. Do you press that again? Yes, you do. Switch it on, 18 volts, that should be all right. So this comes on because it's got quite a wide range of voltage capability on its input. There is actually a little buck converter on here. There's a little inductor there. Let me go back to the eBay listing actually and just check the input voltage range of this thing. Right, the listing is gobbledygook, but it says between 6 and 60 on the input, but then it says something about the expenditure range is up to 48. And I think what it's saying is don't go above 48. I don't know what it's saying, to be honest. Well, now what I know so far about this thing is that all the buttons work on either a single click or a press and hold, a short click or a long click. I don't think there's any double clicking involved. So we've got 18 volts there, which ties up with that. Oh, quite precisely, actually, although this is only 1 decimal place. To set the thresholds on this, you press and hold the middle button. To see all the settings, you single click the middle button. So shall we do that first? Let's come in a bit closer. Press the middle button and we get up 29, down 21, op, dop and fop. Now op, dop and fop are all timers of some description or other, and I'm not using any of them, but I did work out what they all were, and I will go through them all by trying to read the unfathomable instructions. But anyway, let's set the thresholds first. So if I'm going to be winding this thing up between about 12 and 24, let's set an upper threshold, and you press and hold for this, and it starts flashing. So the upper threshold, I think it's up at the top and down at the bottom. I want to set it about, say, 22. 29 was what I was using for my, and it flashes on off, which makes doing this quite tricky actually. So up 22, down let's do 18 for the moment. Let's bring that down to 18 volts. No, that's gone too far. And then we've got op, which is, I think, hours. And then the next one is op minutes. Then we've got dop, and that says it's in hours, but I think it might be in minutes. This display, I think, is a power bank display, and it's not actually intended for this product, but it kind of just works. So I think that's minutes for dop, and then fop is, well, it says hours there, but I don't know whether it's actually hours or minutes. I've no idea. The display actually here, I can see from my angle that there's a capital A and a lowercase h. So this is intended to show amp hours, but you can just fire up the H and therefore it shows hours. But I can't remember whether it is hours. We'll come back to that. Anyway, that's the end of the programming. Press and hold that button again and it writes those parameters in. So I've got 22 as my upper threshold and 18 as my lower. So let's make sure we can see the bulb. And I think I need to set voltage. A couple of clicks on there to get to digits. So if we go to 19, oops, I did 2 clicks, I think, 21, just about 22. So the upper threshold has been exceeded, and so therefore the load is turned on. Now you would imagine that the load would start draining the battery down. So let's drain it down to 21, down to 20, down to 19, down to 18, and because it dipped below 18, it switches off. Now I've discovered that after it switches off because of low battery, this thing flashes for whatever reason. You can stop it flashing by doing a single click, I think, on any button. Yeah, a single click on any button and it stops the flashing, but the flashing tells you that the battery had dropped to a low enough voltage that it triggered the lower voltage threshold, turned the relay off, and the load goes out. Now, as I say, I believe that this display was intended for power banks. So it's got an in and an out marker. And I think if it says out, then this works as a discharge controller or a load controller. If that is set to in, this works as a charge controller. So you would attach the battery to here and a charger to this point here. So when the relay turns on, your charger, which might be a mains battery charger, will connect to the battery and start lifting the voltage up. But in my case, I've got a load here. So when the relay turns on, the load connects to the battery and the voltage will go down. But let's put it in the other mode now. We'll put it in the in mode. So that's charge control. This won't be a charger, this will be a bulb, but we'll see how it works. And I believe for this, we press and hold the top button. I'll have to check that. Yes, it is press and hold the top button, but you have to press it and hold it for quite a long time. About 5 seconds, I think. Now that changes it to P1 mode. So it's now saying in, so it's now a charge controller, but it's also now saying NBE, and I'm not quite sure what that means. Well, I've gone through another few eBay listings for this item, and they're all the same. They've all got the same set of instructions, and nowhere on any of them does it mention what NBE is. The only thing I can think is that in this mode, where you would expect to have a battery charger on this side and the battery on this side, maybe it's looking to see if there is some voltage across here. And obviously with the bulb on there, there isn't. So maybe that's saying that you haven't got a battery charger. But I don't know what NBE means. So perhaps I should limit my use of this thing in this video to its use as a discharge controller. In other words, a load-based voltage-controlled switch, which means putting it into the other mode. So press and hold the top button for a very long time, and that puts it in P2 mode. It is now a discharge controller. We've got 20 volts coming in, which is what we've got, and it hasn't turned the relay on, but there is some timing parameters which I set for op, dop, and in discharge mode you also get this additional parameter fop. Maybe we should go through those. So I think op is an on-time limiter. Now op you have fairly fine control of. If I press and hold set, up voltage 22, down voltage 18, but op you have two fields. So let's set it, I think this is hours actually, let's set it to no hours and 1 minute. Then you have dop. Now dop appears to be, wait a second. Yes, dop is a delay timer between the on and off times, so that you can't have the relay going on, off, on, off, on, off, on, off, on, off really quick like that. And you set dop in seconds. So let's set that to 10 seconds. That limits the rate at which the relay can be turned on and off. And fop is unique to the discharge function, and it is the discharge conduction forced start time. I'll read that one. Yes, this says after the relay is forced to conduct, it will stay on for this forced conduction time, and it can only be up to 10 seconds. So let's just scroll up and see what that does. Yeah, that only goes up to 10 seconds. So let's set it to 10 seconds, see what it does, so we can save that by pressing and holding. Okay, so we got 16 volts. To trigger the lamp, we need to turn it up to 22. That was the upper voltage setting. So let's go 17, 18, 19, 20, whoops, 21, 22. That's turned it on, and now we've got the F counter doing the 10 seconds forced conduction timer. That means that it can't drop out again until that 10 seconds has elapsed. Now are we looking at the other timer? I think we are, because out is flashing, and I think I set that to 1 minute, and I think that's a timer before which you can't make it go off again. So let's try that. So let's go under the trigger threshold. No, that has gone off. So it's still baffling. I'm just thinking maybe fop overrides dop. Op is 1 second. Dop and fop are both 10 seconds. So let's just do a dop without a fop. I'll just program that in. Well, I'll turn off the op, second field for that, off. Dop, I've got 10 seconds. I think that goes higher. Yeah, I think that goes up to 999 seconds. So that's right, fine, but I'll have no FOP. FOP, I think, is limited to 10 seconds. So let's set that down to nothing. Save that. So now we're looking at DOP, and this is a delayed on-time timer, I believe. So let's turn the voltage up. 17, 18, 19, 20, 21, 22. That's come on immediately. Maybe it's a delayed off-time controller. Am I still in that field? Yes, 21, 20, 19, 18. That's flashing, and we've got a countdown. Oh, maybe that's a delay before you can turn it back up again. I'll have to test that. So let's turn it up to 22. That comes on. Turn it down to 16. That goes off. Turn it back up to 22. Yes. And there's a timer. So it stops it coming back on again until that 10 seconds has elapsed, which might be useful if you have thresholds which are very close to each other, or you've got wild variations in battery voltage and you just want to make sure you put in a delay to stop it oscillating. Could be useful, not necessary in my application. I could just smell the bulb then, so I think it's all getting a bit hot here. Now this a single press on this bottom switch is an override, so it's a relay override. So you can manually switch it off or manually allow it to function as per the voltage thresholds. So I think they kind of call it an emergency off switch. I'll emergency off it because it is all getting a bit hot. Now if I turn this back on with the relay override and I do a single press on the top switch, it switches between time view function. So this appears to be how long the relay has been on, and battery percentage function, or at least the percentage of this figure, this voltage, between your upper and lower thresholds. So my upper and lower thresholds are 18 and 22. If I bring this down to, say, the midpoint, which is 20 volts, we've got 50%. At 21 volts, we've got about 75%. And at 19 volts, we've got about 25%. So that shows you the percentage where you are between your two trigger points. This switches between percentage and time, and this appears to show how long the relay's been on. If I override the relay and turn it back on again, does it start that again? No, it seems to not worry too much about that. So that's how long the relay has been on, how long your load's been on. So to summarize the short presses, the top button switches you between two display modes, a percentage mode and a time mode. The middle button reviews all your settings, up, down, op, dop and fop in the case of discharge mode. And the bottom button is this relay override, this emergency off thing. Now press and hold, the top button changes between the two modes, charge controller and discharge controller. The middle button takes you into the parameter programming, so the upper voltage, the lower voltage, the op, the dop and the fop, which are all timer settings. And if you press and hold the bottom button, oh, I don't think we've done that one. Let's see what that does. That's low power, but what it actually means is that after a period of time, the display shuts off, and of course its backlight also shuts off. So that was low power on, I think. Press and hold that one. Low power off means the display never shuts off. Yes, that's what press and holding the bottom button does. So those are the 6 sort of function areas. Now, as I say, in my setup with the solar powered battery, lithium iron phosphate 8 cell, I don't need any of these time functions. So if I go back into programming mode, I've got my up voltage, my down voltage. I don't want any op. I don't want any dop, so I'll take that back down to 0. And I don't want any fop. So press and hold the set button to save those parameters. And now it's simply a case, now that's saying off. Yes, I need the relay functionality back on. That off means that it's got this emergency override thing where the relay will never function. So press that button, press that a couple of times, take it up above the 22 volt threshold, the relay turns on. Take it down below the 18 volt threshold, the relay turns off. It's as simple as that. And without any timing functions, this works on my Solar Crypto setup. Now previously I was using this unit, and I think I did do a sort of review of this unit, but it had a couple of problems. Well, the first problem was that the voltage varied wildly. This was connected directly to the battery, and this voltage was varying 400 millivolts. It was just wandering about, so it wasn't a very good display. Then one day I powered it up, and the little inductor there smoked and blew up the regulator. Now I believe this is an XL1509. This also has a buck controller, but I think it's a different XL chip. I'll have a look. Yes, this one is an XL7005. Now, is the XL7005 better than the XL1509? It's a higher number, so perhaps it is. Now, I think I found a feature which I haven't been using, which is to put this not in percentage mode, but in time mode, trigger it. So let's change the voltage to above the trigger threshold. 22, so that's triggered it. And now I believe that this starts counting up. So let's do the relay override so that my mat doesn't get too hot. But let's let this count up a couple of minutes and then take it down below the undervoltage threshold, which will turn the bulb back off. The bulb is effectively now on, but I've overridden it with the bottom button because I think it will give you a display of the total time that the load was switched on. Let's see if that's the case. Yeah, so this has clocked up 1 minute of on time, and it doesn't appear to interrupt the counter or the timer if you manually intervene and switch this off. So I'll leave that off for a couple of minutes, clock up some on time, then I'll reduce the incoming voltage so that the relay switches off, and see if it remembers that time and displays it so that you can, after I've had a sort of mining session, I'll be able to see on here how long that mining session was. See if that works. Right, so this module has been switched on. Now I've overridden it so I don't melt my mat. So let's switch it back on. That flashes for a bit. So it's been on for 3 minutes. Let's now change the battery voltage so that it goes below the lower threshold. A couple of clicks on there. 21, 20, 19, 18. That switches off. It flashes, but it seems to hold that time. So that could be useful. You can come in, see that this is flashing, that the miner has done a mining session, but it's now stopped, and that's how long it was mining for. Yes, I've not used that. That's quite handy, isn't it? And then if I turn this voltage, battery voltage, back up to above 22 volts again, that should trigger, and the timer resets itself to 0 and starts counting up all over again. Great stuff. So there it is. I've not shown it in charge controller mode, but it works fantastically in discharge controller mode, and that's what I'm using it for. It's got this 30 amp relay, which is more than enough for my current setup. Now if I put a bigger miner on the output of this thing, all I need to do is relay this relay into a much bigger relay and have that control the main current. But at, I think, something like about 12 amps. Now, is this at the high voltage? No, this is at the higher voltage, the lower current. So this gets mildly warm, the relay, but not alarmingly so, like this one, where the 12 amps going through it was, strictly speaking, above its rating, which is 10 amps. This got very hot, but the 30 amp relay, of course, just gets nice and mildly warm. So that works fine. for the sort of 12 or so amps that I'm currently putting through it. And just to go through the op, dop and fop again. Op is a total on-time limiter, and it can be several hours. You can set hours and minutes, so that if you're, for example, this thing is running on voltage thresholds, but you're concerned that you don't want to charge for, say, more than 5 hours, then you could set op to 5 hours, and it would limit the on time of the relay to that setting. Dop is the delayed conduction function. So when the threshold is reached, this thing will not switch on the relay immediately, and you can set up to 990 seconds. And I think that's to stop this thing, if you've got very short cycles, switching on and off too frequently. And then FOP is the forced conduction. That means that when the relay is triggered, it can't then be untriggered again for a period of time, and that's just adjustable between 0 and 10 seconds. So yes, plenty of timing functions. You've also got the ability to look at this in terms of total on time or percentage. Now this is not percentage state of charge. It's nothing to do with the state of charge of the battery. It's simply the percentage voltage that this is currently at between its upper and lower threshold settings. So as I say, this works extremely well in my particular setup where I'm controlling a quite high current load. The instructions, the sort of operating system is unfathomable, as is always the case. You've pretty much got to work it out for yourself. But as I say, in my setup, it seems to work beautifully, and the voltage reading is extremely stable. So I'm very pleased with it. So I'll put a link to this item in the description below the video where I bought it on eBay. But I think for this video, that's probably enough faffing about. So cheerio.